In this video, we are going to solve a question concerning the cofactors of a given matrix. The question is this: if matrix A is a 3 by 3 matrix and A inverse equal to this 3 by 3 matrix, then what are the cofactors of A sub 1, 2, A sub 2, 3, and A sub 3, 1? To solve this question, it's possible to find matrix A from the given inverse matrix and then determine individual cofactors, but this part is somewhat lengthy. In this section, I will introduce you a relatively shorter path. The given is A inverse. A inverse is related to adjoint of A by the formula A inverse equal to adjoint of A divided by determinant of A. Our intention to find adjoint of A is adjoint of A means simply the transpose of cofactors. So if we find adjoint of A, it's simple to determine the cofactors. If we multiply crisscross, we find that adjoint of A equal to A inverse times determinant of A. Determinant of A is equal to 1 over determinant of A inverse. So this expression can be rewritten as A inverse times 1 over determinant of A inverse. As I mentioned above, our intention for determining adjoint of A is to find the three cofactors, because adjoint of A is simply transpose of cofactors. Therefore, once we determined adjoint of A and its transpose, we can trace the three cofactors by observing the row and column they are located, which are already expressed as subscripts. To find adjoint of A, the only thing what we are expected to do is to calculate determinant of A inverse. Determinant of A inverse equal to all the elements of A inverse are different from 0. Thus, the steps we are going through are the same. Whichever row or column is chosen as the coefficient of the 2 by 2 matrix we are gonna form. For this particular case, let's choose row 1 elements as the coefficient, because it's easy to assign the signs of the coefficients since the assignment starts from the first element of this row. In assigning the sign of the coefficients, the rule we are following is to make positive and negative signs alternatively, starting from row 1, column 1 element. The sign of negative 3 is positive. Positive times negative is negative. Thus, minus 3 times the determinant of the first 2 by 2 matrix. Let's form the summation first, and then we will find the elements of the 2 by 2 matrices. The sign of 2 is negative, so minus 2 times the determinant of the second 2 by 2 matrix. The sign of 1 is positive, thus plus 1 times the determinant of the third 2 by 2 matrix. To determine the elements of the 2 by 2 matrices, we have to remove the row and column containing the coefficients. Negative 3 is in row 1, column 1. Removing them left us with these 4 elements. 2 is in row 1, column 2. Crossing them out gives us negative 10 and 4 in the first row of the 2 by 2 matrix, and 8, negative 3 in the second row. 1 is in row 1, column 3. Eliminating them left us with these 4 elements. To find the determinant of the 2 by 2 matrix, we have to multiply main diagonal elements, and from that product, we have to subtract the product of the remaining 2 elements. Thus, this summation is equal to negative 3 times 5 times negative 3 minus negative 4 times 4 minus 2 times negative 10 times negative 3 minus 8 times 4 plus 1 times the determinant is the determinant itself. Negative 10 times negative 4 minus 8 times 5, which is equal to negative 3 times 5 times negative 3 is negative 15. Negative 4 times 4 is negative 16. Minus negative 16 means plus 16. Minus 2 times negative 10 times negative 3 is 30. Minus 8 times 4 is 32. Plus negative 10 times negative 4 is positive 40, minus 8 times 5 is also 40, which is equal to negative 15 plus 16 give us 1, negative 3 times 1 is negative 3. 30 minus 32 is negative 2. Negative 2 times negative 2 gives us positive 4. 40 minus 40 gives us 0. Negative 3 plus 4 plus 0 equal to 1. Hence the determinant of A inverse is 1. So adjoint of A equal to A inverse times 1 over determinant of A inverse is 1. 1 divided by 1 is 1. 1 times A inverse is A inverse itself. Therefore, adjoint of A is this 3 by 3 matrix. It's known that adjoint of A is the transpose of cofactors. In other words, if we transpose adjoint of A, it gives us cofactors of matrix A because transpose of transpose is equal to the original matrix. So let's find the transpose of adjoint of A. Column 1 of adjoint of A becomes row 1 of transpose of adjoint of A. Column 2 of adjoint of A becomes row 2 of transpose of adjoint of A. Column 3 of adjoint of A becomes row 3 of transpose of adjoint of A. These elements represent cofactors of matrix A. Cofactor of A sub 1, 2, which is designated as C sub 1, 2, is the element located in row 1, column 2, because this first subscript stands for the row and the second subscript stands for the column where the cofactor is located. The element in row 1, column 2 is negative 10. By the same analogy, cofactor of A sub 2, 3, which is designated as C sub 2, 3, is the element in row 2, column 3, that's negative 4. The cofactor of A sub 3, 1, which is designated as C sub 3, 1, is the element in row 3, column 1, which is positive 1. By this, I wrap up part 20. Have a nice time.